Namaskar. Myself Professor V.M. Patel, Associate Professor in Government Engineering College, Modasa, in Civil Engineering branch. Now, in a continuation of angular measurement, today we will go further. Now we know, let us brush up something which we have already covered. That in an angular measurement, generally, whenever we carry out a survey, two basic things we have to do. One is the linear measurement and second is the angular measurement. In the linear measurement, we can do by using the chain or tape. For angular measurement, we have a number of equipment available, but mostly we are using a prismatic compass. For the measurement of the angle, we have two types of the compass. One is the prismatic compass and second is the surveyor compass. We have already covered all those parts. But when area of survey is small and perfectly level, then generally we go for the triangulation. But if the area of the survey is undulating and crowded with many details, then we cannot use the triangulation method, and for that we have to go for the traversing. Basically, there are two types of traverse. One is known as the open traverse, second one is the closed traverse. Depending upon the requirement of the survey, we are choosing any one of them out of two. Now, in angular measurement, we have to take the bearing. First of all, in the prismatic compass, the reading which we are getting it in terms of whole circle bearing, and in a surveyor compass, we are getting the reading in terms of reduced bearing, that is, we can say quadrilateral bearing. What is bearing? First of all, bearing is nothing but the angle measured with reference to some reference line. Now, generally, we are taking the two reference lines. Already there are four, but mostly we are using two. One is known as the magnetic bearing, and second is known as the true bearing. What is meant by magnetic bearing? If we join the magnetic north and magnetic south, and if we measure the angle with reference to that line, that is called as the magnetic bearing. But if we join the true north and true south, and if we measure the angle with reference to that line, that is known as the true bearing. Theoretically, both should be same, but practically there is a certain small angle. This deviation is varying, depend upon the day in which you are carrying out the survey. This variation it takes place throughout the year. Now, in a prismatic compass, there is a one freely magnetic needle which is freely suspended on the pivot, and each will indicate the north and our line of survey that we are measuring. Now, we are getting the bearing from 0 to 360, that is known as the whole circle bearing. In quadrilateral bearing, or we can say in surveyor compass, we are getting the bearing in terms of reduced bearing, or we can say quadrilateral system. That means from north to east, we can say quadrant 1. From southeast, we can say quadrant 2. From southwest, we can say quadrant 3. And from north to west, we can say quadrant 4. So the maximum reading that we are obtained in reduced bearing is 90 degree. But we have to indicate the direction. That means north to east, south to west, or north to west. And from that we are getting. Now there is a system that we have to convert. Sometimes the reading is given in whole circle bearing and we require in terms of reduced bearing. Sometimes we have given the reading in reduced bearing, we have to convert to the whole circle bearing. So that part we have already covered. Now, in traversing, in the direction of the progress of survey, if we are taking the bearing, that is known as the forebearing. And in the reverse direction of the survey, if we are taking the bearings, that is known as the back bearing of the line. Difference between forebearing and back bearing is 180 degree, always. So, if the one reading is given, suppose forebearing is given, then very easily we can calculate the back bearing. Or if it is back bearing is given, we can easily calculate forebearing of the line. Now, this angle measurement of the prismatic compass, it will not give a direct angle. But by using a calculation, we can find out the angle between two lines. Now, how to find out the angle? That part we have already covered in the previous lecture. Again, one more thing you have to keep in your mind, whenever you are carried out a survey, if your area of survey or the station where you are going to measure an angle or where you are set up your instrument, if it is affected by magnetic influence, that means suppose there is a magnetic rock near it, or electric line is passing below your station which is carrying a high current, or there is a steel structure which is near to you, or if there is a bunch of key in your pocket, then your compass will not show a correct reading because it is a magnetic needle. So it will influence, it will attract toward this structure because this is a steel structure. And because of this attraction, your reading is going to be wrong. This phenomena is known as local attraction. This phenomena is known as local attraction. We have to carry out a certain correction to remove that correction. Now, if we go or if we define, so there are two types of sources of error because of the local attraction. Because of local attraction, one is known as the natural source and second one is known as the artificial source. We define the source of error in a two way. One is called as a natural error, second one is known as the artificial resource. Natural error, it is because of the iron or magnetic rock. Generally we cannot see all these things. The second part, that is artificial, that means if your station is very near to the steel structure, or if there is a pole, electric pole, or if is a electric line which is passing below your station, or if there is a bunch of key, or if there is a specs which is having a steel, then your needle is attracted and it will give a wrong result. So these are the two sources. As we have discussed, how we can detect or how we can find out, how we are able to know that there is error. Our station is affected by error or local attraction. We have previously discussed that the difference between forebearing and back bearing is 180 degree. So if we find out in our traverse, when we carry out the traverse, when we plot the traverse, when we count after taking the reading, when we come to our office and we find out the difference between forebearing and back bearing, and if our difference is not 180 degree for any line, that means any of our station is affected by local attraction. That we can find out. Now see here, see the example. Here suppose the observe forebearing of line AB, it is 80 degree 30 minutes. And observe back bearing of AB, that is 260 degree. Now calculation of back bearing of AB, suppose AB is given here 80 degree. We know that if the forebearing is given, back bearing we are able to calculate, and if back bearing is given, forebearing easily we can calculate. Here the back bearing is 80 degree 30 minute. It is because it is less than 180 degree, we have to add 180 degree to calculate the back bearing. So if we add 180 degree, our reading is 260 30 degree. Now this is the calculated, and our observed bearing is 260 degree. Both reading are differ by 30 minutes. So what we are doing, whatever the error, we are dividing into the two parts. So the corrected back bearing of the line is equal to 1/2 observed bearing and calculated bearing. Observed bearing and calculated bearing. So observed bearing A is 260 and calculated bearing is 260 degree 30 minutes. So our reading is 260 degree 15 minutes. So this is right, or corrected back bearing. Now we have a corrected back bearing, then forebearing easily we can calculate by using this figure. We find out, because this figure is above 180 degree, simply subtract 180 degree, so we can calculate the forebearing of the line, and which is equal to 80 degree 15 minutes. This is the right things. Now method of correction, we can do our correction by two ways. There are two methods to apply the correction or to remove the correction for the local attraction. Our first method is that interior angle method. We can say interior angle method. So first of all, for our traverse, calculate all the included angle. Calculate all the included angle, and then finally apply check, which is 2n minus 4 into 90 degree. And if your total sum of angle, if it is not matching with 2n minus 4 into 90 degree, that means there is a certain error. If there is no error, then go ahead for the correction of the bearing. If there is an error, then it is equally distributed among all the angle of the traverse. Then finally calculate the corrected angle. then starting from the unaffected line of the bearing, all other line corrected bearing is calculated. How you can find out the unaffected line? We have already told you that if the difference between forebearing and back bearing is 180 degree, then this line is free from local attraction. If the difference between forebearing and back bearing is not 180 degree, that means there is a local attraction. So out of traverse, we have to find out at least one line or the line which is having a minimum error. And if there is a minimum error, then what we have seen in the previous example, same way we correct the forebearing and back bearing, and then by using our angular angle, we find out the all bearing. In the second method, that means here the internal angle are not calculated, but the unaffected line is first of all detected. And by using of unaffected line, we start from that and we calculate all the bearing by using forebearing, back bearing, forebearing, back bearing, and we correct first of all the bearing. And then we go for the calculation of the internal angle. So these are the two methods. Now let us see and clear our things. Here the example is given that the following bearing were observed with a compass for the closed traverse A, B, C, D, E, A. The line is given A, B, B, C, C, D and D, A. Because it is a closed traverse, the starting point is A and ending point is A. The forebearing is given 120 degree, here back bearing 300, 200, 20, 3, 110, 10. Now the question is, where do you suspect the local attraction? Find the included angle and correct the bearing for the lines. Now we have to calculate, first of all, find out where or which station is affected by local attraction, as well as we have to calculate the internal angle. Now before solving any problem of the compass, first plot a traverse. First plot a traverse by approximation. Here we have given one point is marked on the paper. Forebearing of the line AB is 120 degree. So approximately draw a 120 degree angle and draw a one line AB of any length. Then marks a point B. From point B, we have a bearing of BC line, that is 200 degree. So 200 degree approximately it comes here to here. So we draw a another line, line BC. Now we mark a C and we have a forebearing of the line CD, that is 310. So we draw another line of CD, and from D, because it is a closed traverse, and approximately see that the bearing of DA, it is given 30 degree, approximately we join this line to AA. So this is our complete traverse. Now in our example, a back bearing is also given. So mark back bearing. Here the back bearing of DA, it is 209, it is given. So mark 209. Back bearing of the line AB is 300. So mark over, this is the angle 300. Here the back bearing of the line CD, it is 131. So mark over here. So once you plot this thing, then go ahead for the calculation of internal angle. For the internal angle, now it is very easy, because while plotting, you are able to understand that in which angle the knot line is come inside and for which angle the knot line is come outside. Because the calculation of the internal angle, it is very important. By simply observing the bearing, you cannot say that here you are able to see that for the station C, the knot line is inside. For all the station A, B and D, knot line is outside the station. How you can calculate angle A? Angle A, how you can calculate? From figure, we can easily that if 209 minus 120 degree, you are able to find out the angle A. What is 209? It is nothing but the back bearing of DA, and this is forebearing of AB. So angle A is nothing but the back bearing of DA minus forebearing of AB. You will able to calculate the angle A. Similar way for the angle B. Here you able to see that 300 minus 200, that is the angle B, internal angle. What is 300? That is nothing but the back bearing of line AB, and here the forebearing of the line BC. So you are able to calculate the angle B. Suppose how here? Here you have to apply your mind. This is the complication, because for the calculation of the C, there are two ways. Number one, that means suppose this part, this angle is already given. Suppose your back bearing of BC is 20 degree. So this part is already with you. Suppose you calculate this part, then the summation of these two, it will give angle C. Now this part is nothing but the 360 minus 310. What is 310? It is nothing but the forebearing of CD. Or there is another method that suppose you find out the exterior angle. Then subtract this angle from the 360 degree. So exterior angle and find out the exterior angle. This is nothing but the 310 minus 20. It will give the exterior angle of C. So what is 310? We can say it is a forebearing of CD, and here this is a back bearing of BC. So you will get the exterior angle, and 360 minus exterior angle. So you are able to get the interior angle of C. Similar way for the angle D. From the figure you are able to easily understand that 131 minus 30, that you are able to calculate angle D. What is 131? It is nothing but the back bearing of CD, and 30 is nothing but the forebearing of DA. So apply this formula for the calculation, but if you are able to know all these things, then and then, if you draw the figure, then and then you are able to calculate. Then first of all, calculate all angle. Calculate angle A, angle B, angle C and D. Then apply check. What is angle of, what is check? 2n minus 4 into 90. What is the n? Number of side. Here for our traverse A, B, C, D and A. This is our closed traverse. So there are 4 sides. So value of n is equal to 4. 2 into 4, that is 8, minus 4 into 90. So that is a 360. If your summation of angle is 360, then there is no require in correction for the internal angle. But if there is a slight variation, it is a 361, or you can say less than 359 or anything else, then you have to apply correction. Whatever the correction is there, find out, equal, divide by number of angle, equally distribute. See how we calculate all these things. Now, first of all, we put the line, forebearing, back bearing, and find out the difference. Find out the difference. So here AB is 300 minus 120 degree. 300 minus 120 degree, that is 180 degree. Here 200 minus 20, that is 180 degree. Here 310 minus 131, that is 179. 209 minus 30, that is 179. So from this table, you can see that here you are getting 180 degree for the two line AB and BC. Line AB and BC, that means the station A and B, they are giving correct reading. Here station B and C are giving correct reading. Only station D is not giving correct reading. Here the station A, B and C, they are free from the local attraction. And only the affected station is D. Only the affected station is D. Now elimination of local attraction by included angle. First, because we are solving this problem by first method. So first of all, calculate the internal angle, which I have already explained. Angle A is equal to back bearing of DA minus forebearing of AB. That is 209 minus 120 degree is equal to 89. Similar way, angle B, that is back bearing of AB minus forebearing of BC is equal to, from this table, take the value, that is 300 minus 200 is equal to 100. Now, from the figure I have already explained. There are two methods, the 360 minus exterior angle. See, this is nothing but the calculation of exterior angle. So that is forebearing of CD minus back bearing of BC. So 310 minus 20, this will give the exterior angle. So subtract from 360, you are getting the internal angle. And angle D is equal to back bearing of CD minus forebearing of DA, that is 131 degree minus 30 degree is equal to 101. Now, sum of the included angle, angle A plus angle B plus angle C plus D, whatever the angle we have calculated, just put 89 plus 100 plus 70 plus 101, the summation is 360 degree. Apply our usual check, that is 2n minus 40 into 90. And here the n value is 4, So this is 360 degree. So our calculated sum and check is same. So there is no require for the correction in angle. There is no require for the correction in angle. Now our idea is to find out first. In our example, it is given that find out the which station is affected by local attraction, as well as we have to find out the corrected bearing. So here the station A, B and C are free from the local attraction. A, B and C are free from local attraction. So whatever the reading which is taken from station A, station B and C are correct. So first of all, we list out the reading which are free from local attraction. So from the station A, we are taking the two reading, which are that forebearing of AB and back bearing of DA. These two reading we are taken from the station A. Similar way, from station B, we are taking forebearing of BC and back bearing of AB. And from the station C, we are taking the forebearing of CD and back bearing of BC. Value may be anyone. Value may be anyone, but we are taking this reading. So our station A, B and C are free from the local attraction. So all the reading are correct. All the reading are correct. By using this reading, we are correcting our D station reading. Station D is affected by local attraction. So from the D reading, station D, what we are taking? We are taking two reading. Number one is forebearing of DA, which is 30 degree, and back bearing of CD, that is 131. These two reading we have taken from station D, which are likely to be incorrect. Which are likely to be incorrect. Now, how we can find out the correct reading? To find out the correct back bearing of CD, the forebearing of CD 310, which is given and which is correct value. We know that this forebearing of CD is correct. Now using our formula for the calculation of forebearing to back bearing and back bearing to forebearing of difference is 180 degree, apply this equation and we find out the back bearing of CD. Oh, back bearing of CD is equal to 310 minus 180 degree, it is 130 degree. So this is by our calculation. And our observed value is 131. Our observed value is 131. So there is an error of 1 degree. There is an error of 1 degree. Similar way, to find out the correct forebearing of DA, forebearing of the DA, the forebearing of DA is equal to back bearing of CD minus angle D. So we are using here the included angle. We are using angle D. We have a back bearing of CD which is correct. Here we are correcting this reading. So we put this value minus angle. So we are getting the correct value of forebearing of D, that is 29 degree. And once we get this reading, then back bearing of it, here forebearing of DA we are able to calculate. Then back bearing is nothing but simply because this reading is less than 180 degree, simply add 180 degree. So it is 209, which is already given in our example data. It is given here. See, this is 209. So whatever we are finding out this, it is right, because this is a cross check calculated and the given both are same. So the corrected bearings given, now prepare a table of forebearing, back bearing and find out the difference. So now you can see that all the difference are 180 degrees. That means we corrected all the bearing. Now similar way, here this is another example. In the previous example, suppose you have seen the traverse is given in a clockwise direction. Traverse is given in a clockwise direction. But it should not happen always. Sometimes traverse is given in an anti-clockwise direction. Then for the calculation of angle, our formula may be differ. Always we cannot say that back bearing minus forebearing, back bearing minus forebearing. It is depend upon the traverse is running in the clockwise direction or it is running in the anti-clockwise direction. So this is another example. See, this is certain different thing. In the previous example, when we find out all the angle and we carried out the summation, it is exactly 360 degree. But if our included angle summation is not 360 degree, then what we should do? We clear our idea by solving this example. See this example. The bearing of observed in a traverse survey conducted with a compass where local attraction was suspected. Here it is given already that your traverse is suspected by local attraction, so all the reading are not correct. The reading is given line AB, forebearing and back bearing, it is 124 degree 30 minute, here 304 degree 30 minute. For line BC, forebearing is 60 degree and back bearing is 246 degree. For line CD, it is 310 degree and 30 minute, here 131 degree 30 minute. For the line DA, it is given 200 degree 30 minute and here it is given 90 degree 30 minute. Now what is the question? Our question is, at what station do you suspect the local attraction? First of all, find out the station which is affected by local attraction, and second, find the correct included angle and correct bearing. We have to do both these things. Here we are carried out the correction in the angle as well as we have to carry out the correction in bearing. So it is different from first example. Now as we have done in the previous example, or we have to do in every example, rather to calculate whenever we require a calculation of the internal angle, first of all we have to plot the traverse. This is the basic requirement. If you are not plotting and simply memorize the equation, you may making a certain mistake. So plot the traverse according to the measurements. So here the bearing is given forebearing of the line AB, it is given 124 degree 30 minute. So simply here this angle is approximately 124 degree 30 minute. Draw a line AB of any length. Then from B, again mark a knot line on the upward side. Now the forebearing of line BC is 68 degree. So 68 approximately it comes over here. If it is 90 degree, it will be like this. If it is more than 90 degree, it is like this. If it is more than 180 degree, it is like this. And if it is more than 270 degree, it is like this. So in which quadrant you are drawing the line? From a common sense, you can draw this line. So use the forebearing of the line BC of 68 degree, draw a line BC. Now from B, draw a line CD, because forebearing of the line CD is given 310 and 30 minutes. So it is in the fourth quadrant. So draw a line in a fourth quadrant of any length and mark a station D. Again mark a knot line and use the data which is given, that is forebearing of the line DE, which is given 200 degree 80 minute. Now 280 comes in a third quadrant, so we draw a line in a third quadrant, and because it is a closed traverse, we join D and A. Now on the traverse we put forebearing and backbearing the data which is given to us. So first of all mark it, because once you know these things, it is very easy to calculate example. Now here our first example is in clockwise, A here, B, then C and D. Here it is a something else, anti-clockwise, A, B, C and D, anti-clockwise direction. So here how we can calculate angle A? So it is very easy, that 124 degree 30 minute minus 90 degree. So it is forebearing of AB minus backbearing of DA. Backbearing of DA. What we are doing in a previous example, we are doing a backbearing minus forebearing. Backbearing minus forebearing. Here the equation is changed. So here the knot line is at station B, it is come inside. So for calculation of the internal angle, again I am repeating that you can calculate this angle, interior angle, by two ways. Because here the forebearing 68, this angle is given 68. Let us see the marker. See the marker. This angle is given 68. So if you calculate this angle and summation of these two angles, it will give the internal angle. How you can calculate this internal angle? 360 degree minus this angle. What is this? This is nothing but the backbearing of AB. Backbearing of AB. So you are able to calculate this. So this plus 68 degree, this is the internal angle. There is another method, that suppose you find out the exterior angle, and if you subtract from 360 degree, you are getting the internal angle. So 360 degree minus here the backbearing of AB minus forebearing of BC, it will give the exterior angle, and in 360 minus exterior angle, this is angle B. Similar way for calculation of the C, if you are interested in calculation of this angle, this is nothing but the forebearing of CD minus back bearing of BC. It will give a angle C. And for angle D, we are doing a forebearing of DA minus back bearing of CD. It will give the angle D. And then carry out the summation. Now see here. First of all, what we are doing? Here write down all the forebearing, all the back bearing, and find out the difference of forebearing and back bearing of all the line. For AB line, we are getting the difference, which is 180 degree. For BC line, we are getting the difference of forebearing and back bearing. It is 178 degree. For CD line, difference of forebearing and back bearing is 179 degree. And for DA line, difference of forebearing and back bearing is 181. Here see that one is difference 178, 179, 180 and 181. All four difference are we are getting different, but we know that the difference of forebearing and back bearing is 180 degree and it is of line AB. So the reading taken from A and B are perfect. So station A and B are free from local attraction. Station A and B are free from local attraction. And for C and D, they are affected by local attraction. Station D and C are affected by local attraction because we are not able to calculate the difference 180 degree over here. So we have to apply certain correction. So we find out that station A and B are free from local attraction and station C and D are affected by local attraction. First of all, we calculate the internal angle because we apply the first method. When we go for learning of the second method, then we will learn other things. So our calculation of the included angle. So angle A, forebearing of AB minus back bearing of DA, that is 124 degree 30 degree minus 19 degree 30 minutes, that is 105. Angle B, as we have seen that here, see this is angle B, north line is come inside the traverse. So we are calculating these two ways. In the previous example, I have calculated 360 minus exterior angle. Here I have calculated exterior angle first. So exterior angle is equal to back bearing of AB minus forebearing of BC, that is 304 degree 30 minute minus 68 degree, that is 236 degree 30 minute exterior angle. And for interior angle, it is 360 minus exterior angle of B, that is 360 minus 236 degree 30 minute is equal to 123 degree 30 minute. Same way, calculate the angle C, that is forebearing of CD minus back bearing of BC, that is 310 degree 30 minute minus 246 degree 00 minute is equal to 64 degree 30 minutes. Angle D is equal to forebearing of DA minus back bearing of CD, that is 200 degree 30 minute minus 131 degree 30 minute. So our angle is 69 degree 00 minute. Now we calculate all the angle. So do the sum. Sum of the angle is equal to angle A plus angle B plus angle C plus angle D. That is 105 degree 00 minute, 123 degree 30 minute plus 64 degree 30 minute plus 69 degree 00 minute. And the summation is 362. Now apply check. Our checking equation is 2n minus 4 into 90. And we have a traverse which is having 4 sides. So the value of n is 4. So 2 into 4 minus 4 into 90, that is 360 degree. So our checking angle and calculate angle are not same. So our traverse is not perfect. We have to apply correction in angle also. Here 2 degree, 362 minus 300, 2 degrees more. Our summation should be 360. Our summation should be 3 degree. How we can correct our included angle? Let us see. Total error, that is calculated angle, is 362 minus checking angle is 360. So here it is a 2 degree. 2 degree, that means it is 120 second. 1 minute is equal to 60. 2 degree, that means 120 minutes. 2 degree, that means 120 minute. And because our summation is more, so our correction is negative. Our correction is negative. It is here it is 120 positive, so correction is minus 120 degree. And we have a 4 angle. So this error, if we divide into all angle, so minus 120 divided by 4, that is 30 minute. Minus 30 minute, we have to apply correction in all angle. So first of all, write down angle A, angle B, angle C and D, and from all the angle apply correction of minus 30 minute. So here 105 degree 00 minute minus 30 minute is equal to 104 degree 30 minute. Angle B is equal to 123 degree 30 minute minus 30 minute is equal to 123 degree 00 minute. Same way, angle C is equal to 64 degree 30 minute minus 30 minute, so that is 64 degree 00 minute. And here angle D is equal to 69 degree 00 minute minus 30 degree, that means 68 degree 30 minutes. Now you look about the summation. Our summation is 360 degree and our check is also 360 degree. So all calculated angles are now right. This is our corrected angle. Whatever we have calculated, this is wrong. This is the wrong. Calculated is the right. So right corrected angle is this. Now we doing the first part, that means we corrected the angle. Now we go for the correction of a bearing by using a included angle. So how we can do these things? So that is, if you look about the figure, first I will explain and then we will doing calculation. Suppose here suppose the difference is 180 degree, it is given over here. That means A and B station are free from local attraction, that we are knowing. Now go to the figure. Here A station and B station are free from local attraction. So whatever the reading taken from A and B are right. Now B reading is from V, we have taken the reading of 4 bearing of BC. That is right because B station is free from local attraction. So if this reading is right, 4 bearing, then from 68, if we add 180 degree, then we are getting a back bearing. So if we calculate the back bearing, it is right. So once we calculate back bearing, and then if we add the angle C, add this here, see the marker. If we calculate the back bearing, correct back bearing, that means 68 plus 180 degree, we are getting a correct back bearing of line BC. Then if we add this thing, then this angle is to be added and we find out the correct bearing of line CD. We find out the correct bearing of line C. Forget about the previous reading. So we find out the correct 4 bearing of line CD. Then again go for the difference of 4 bearing and back bearing 180 degree. So here whatever the reading you are getting, simply subtract 180 degree. So you are getting correct back bearing. Correct back bearing you are getting. So once you have a correct back bearing and you have a angle, corrected angle of D. So correct back bearing plus if you add the angle D, you are getting a correct 4 bearing of line DA. Correct 4 bearing of line DA. Okay. So once you find out the correct 4 bearing of line DA, plus or minus 180 degree, depend upon the reading. So here you are able to see that our reading is more than 180 degree. So you have to, for getting the back bearing of line DA, you have to subtract minus 180 degree and you are getting a one figure. Here this is observe value. And we know that our station A is free from local attraction. So your calculated value and your observed value should be same. Because this is free from local attraction. And here you are getting a calculated value. So both values should be matched. Then and then your example is right. So automatically you are getting a check that your example is right or wrong. Let us see by calculation. Let us see. First select the line whose 4 bearing and back bearing differ exactly by 180 degree. Here the line AB, 4 bearing are differ exactly by 180 degree. So both 4 bearing and back bearing are correct. So first consider line AB. So 4 bearing is 120 degree 30 minute and back bearing is 304 30 minutes. These are the correct reading. Now for the line BC. Line BC, here because from the station B, we are taking a back bearing of line AB, which is right, which is correct. So by using this minus, we have a exterior angle. So simply put the value 304 degree 30 minute minus exterior angle of B, which we have already calculated. So put this value, that is 360 minus internal angle, that is 123 degrees 00 minute. So you are getting the value, that is 67 degree 30 minute, which is a correct forebearing of line BC. Okay. Now we have a forebearing of line BC. Now we can calculate the back bearing. Because this figure is less than 180 degree, simply add 180 degree to calculate the back bearing. So 68 degree 30 minute plus 180 degree is equal to 247 degree 30 minute. That is the corrected back bearing of line BC. Now we have to calculate the CD, forebearing of CD. Barabar? Okay. So back bearing of BC we have calculated, and we have an internal angle of C that we have already calculated and corrected all the angle. So put here the 247 degree 30 minute, which we corrected, plus internal angle of C, that is 64 degree. So the value which we are getting 311 degree 30 minute, that is the correct reading of forebearing of line CD. Once we get the forebearing, because this value is more than 180 degree, back bearing easily we can calculate 311 30 degree 30 minute minus 180 degree 00 minute is equal to 131 degree 30 minute. Similar way for the line DA, forebearing of line back bearing of CD plus internal angle of D. Here back bearing of CD 131 degree 30 minute plus 68 degree, it is you are getting a 200 degree 00 minute. And back bearing is 200 degree 00 minute minus 180 degree 00 minute is equal to 20 degree 00 minute. Line AB, forebearing is equal to back bearing of DA plus internal angle of A. Here the back bearing of DA, which we have calculated, it is 20 degree 30 minute, and internal angle of A is 104 degree 30 minute. So here 124 degree 30 minute. This is figure we are getting by calculation, and the figure which we are given, that is also the same. So both are matching. So we can say that our calculation is right. By using this back bearing, it is 124 degree 30 minute plus 180 degree 00 minute is equal to 304 degree 30 minute. And again we are getting this thing also. As I have told you that the A station and B station is free from local retraction. So the whatever the reading which we are getting from station A and station B are right. Station A and station B are right. So this is a one method we can call such first method, that is called internal angle method. Internal angle method. So here we have seen two examples. Number one, where there is no require for correction of the internal angle. Internal angle 360 degree, our checking is 360 degree, there is no requirement. Only requirement that correction in the forebearing and back bearing of a line. Okay. Now in the second example, we have seen that there is a requirement of correction in the internal angle also. Here both example, first one is a clockwise direction, second one is the anti-clockwise direction. Calculation of the internal angle, for the first traverse we are using a certain different equation. For the second example, we are using a certain equation. So don't memorize, I am repeating, don't memorize the equation. First plot a traverse and then see the figure and calculate internal angle and external angle. Because when you plot a traverse, in most of the cases, I cannot say 100%. I cannot say 100%. But in 90% cases, in one angle, your knot line is come inside. So for that, you have to calculate the exterior angle. So exterior angle is required in that case. So without plotting this, we are unable to calculate. We are unable to know that which angle the knot line is come inside. When you do a lot of practice, you are able to understand that from angle C or angle D or angle A, any angle, knot line can become inside. So let us, what we are doing in this lecture, let us summarize. What is the local attraction? Again, repeat. If your station is affected by magnetic influence, what is magnetic influence? If it is near the iron ore or magnetic rock, or that is the natural things. The second one is artificial. That means suppose your station, there is a one wire which is passing below the earth. You can't able to see that because you can't see the wire. If there is an electric pole which is near to your station, if there is a ranging road you put, your station is very near, then also your magnetic needle is slightly deflect because it is a magnet. And any steel structure, or if there is a bunch of key in your pocket, and when you are taking the reading, you are very near to your magnetic needle, so it is deflected side one, so it will not give a correct reading. In that case, you are giving a wrong reading. That is known as the local attraction. And when we doing a closed traverse or survey, what is mean by survey? Survey, that means we are collecting a certain information, ground information, by certain method. We come to our office, we plot the traverse, and whatever the information which we collect, that is put on paper. And that is useful for any civil engineering work. Suppose some drainage work is required, or suppose you are laying electric line, or suppose you want to widening the road. Then what is the existing condition you require for the planning? If you have a clear-cut data with you that your road is 4 meters and there is a certain space available 1 meter on both the side, then you can prepare a channel and you can put the wire. Otherwise, you have to excavate your road. For the drainage line also, because we are facing, every day we are watching that a drainage person, once he's complete his work, then another agency come and start digging, because this is not a proper planning. Suppose we have to develop a road circle, then what is the existing road that we have to require on plan? Then we put and we doing certain planning, and we can expand, or we can do estimation and proposal and all these things that is to be required. So that is important. Again, 99% cases we are using a prismatic compass, but we can use the surveyor's compass also. In prismatic compass, we are getting the bearing, which is whole circle bearing. Value of whole circle bearing is any from 0 to 360. If it is a surveyor compass, then we are getting a reduced bearing. Reduced bearing, we are getting maximum angle 90 degree, but we have to specify the direction, that is north to east, that is first quadrant, from south to east, that is second quadrant, then south to west, that is third quadrant, and from north to west it is fourth quadrant. First figure in the reduced bearing, it's north or south, then put angle, then the last figure is east or west. Now, in whole circle bearing, it is very easy to calculate forebearing to back bearing. In a reduced bearing, it is quite even more easy than the whole circle bearing. Simply you have to replace N to S or E to W. If you interchange both this figure, you are able to calculate forebearing to back bearing and back bearing to. But whenever you require for calculation of the internal angle, we have to use the whole circle bearing. Mostly, you can use a quadrilateral bearing also. So, in the next lecture again we will go further more the second method, how we can correct our bearing and included angle by applying a second method. Thank you very much. Abar.